Hello everyone, I am Professor Ayiswarya. So in this lecture video, I am going to explain about module number 5, kinematics. Okay. So here in the kinematics, I am going to explain about projectile motion. Okay. We shall see what to be done with the projectile motion. Okay. And in the earlier videos, I explained about the equations of motion, okay, motion of gravity, everything. So in this video I am going to explain about how the projectile motion works when coming to numericals. Okay, before that we can see the definition of the projectile motion. So whenever a particle is projected upward, okay, with some inclination to the horizontal, it travels in the earth and traces a parabolic path and falls in the ground, right? So the particle itself forms a curvature path, and that is called a projectile, and the path traced by the projectile is called trajectory. Okay, so this is the path. Imagine you are standing here and throwing a stone. It will fall like a curve, isn't it? So this is called trajectory. Okay. There are some terms used for the projectile motion, that is the velocity of projection, angle of projection, time of flight, horizontal range and vertical height. Okay, see, velocity of projection, range. Okay, so guys, when coming to velocity of projection, it is a velocity with which the projectile is projected in the upward direction with some inclination to the horizontal. Okay, and second one is angle of projection. So the angle with which the projectile is projected with respect to the horizontal. Okay, the time of flight t, it is the total time required for the projectile to travel from the point of projection to the target point. Okay, and next one is horizontal range. It is the horizontal distance between the point of projection and the target point. Okay, and the last one is vertical height. So vertical height means it is the distance or height reached by the projectile from the point of projection. So these are all the varying terminologies used for the projectile to the used for the projectile motion. Okay. So there are few formulas for the projectile motion. They are, see guys, as I said, this is velocity of projection. So it is having the x component and y component. X component as ut cos theta and y component is ut sin theta minus of gt square. Okay, and for x and y you have some formulas like this. T is equal to time taken is equal to 2u sin theta by g, and r equal to u square sin 2 theta by g, and h is equal to u square sin square theta by 2g. So these are all the formulas which derived from earlier derivations. Okay, and from this formulas only you are going to solve the projectile motion numerical. Okay guys, so here I have a numerical. So this says that an aircraft is moving with an horizontally at a speed of 108 km per hour at an altitude of 1000 meter towards the target on the ground. Release a bomb which is hits the target. Estimate the horizontal distance of the aircraft from the target when it releases the bomb. Calculate also the direction and velocity with which the bomb hits the ground. Okay, so you have to calculate, right? So the speed of aircraft is, guys, they are saying that it is moving with a velocity of 108 km per hour. Okay, to calculate that into speed, you need to multiply with 100 by 60 into 30, so you will get 30 meter per second. Okay, and the horizontal velocity is 200 meter per second, right? And the height is 1000 meter, right? It has been said in the question. So you can use a formula h is equal to half gt square. Okay, using that you will get t is equal to 14.278 seconds, and to calculate the horizontal distance you have the formula r equal to u into t. Okay, when the aircraft from the target when it releases a bomb, okay, so you will get 428.57 meter. Okay. And for velocity vertical component, v is equal to gt, 9.81 into time taken, that is 139.9 meter per second, and horizontal component u equal to 0. Okay. The resultant velocity r is equal to root of u square plus v square, and direction is tan inverse of v by u. If you use these formulas, you will get the final formula, like a final answer for the projection, for projectile motion. So thank you guys. This is how you need to solve the projectile motion numericals. So thank you everyone. It's just a substitution of formulas wherever required. Along with that, if you merge the equation of motion, you can able to solve any type of numerical, guys. So thank you everyone.